Welcome to Lab 2 Part 2, where we will cover Scipy, a Python library that has functions for solving equations numerically. In this video, we will cover two functions, root and fsolve, for solving linear and nonlinear systems of equations. Before we start, we must first import the two functions from Scipy. To import root from Scipy, do from scipy.optimize import root. Here we are only importing the function root, not the entire Scipy library. Then to import fsolve, do from scipy.optimize import fsolve. For the first example, we will use both functions to solve this linear system of equations. We must first declare all of our equations in a user-defined function using def, then the name of the function. Here we will use f, round brackets, and the input, let's say params. When using these functions, we will only ever have one input. Set all of your variables x, y, and z equal to the input of the function. Now we can declare each of our three equations. The first one is y1 equal to x plus y plus z minus 5 equals 0. The second is y2 equal to x plus 2 times y plus 4 times z minus 10 equals 0. And the last one, y3 equal to x plus 3 times y plus 9 times z minus 25 equals 0. Then we must return all of our equations in a list. To do this, write return, then a list, then write each of the equations inside your list. Now that we have our equations, we can use the root function. We will set our solution equal to root, round brackets. The first input is the function we just declared, then a list. Then we must give initial guesses for each of the variables. Here we will give 0, 0, 0. All of the initial guesses here correspond to all of the variables we will use. Then we can print out solution. When using root, solution returns all of the details. Since we only want the actual solution, we just want x. So we can do solution.x. And here we have our solution, where 10 corresponds to x, negative 10 is y, and 5 is z. We will now solve the same equation using fsolve. We will first copy over our equations, then we will set our solution equal to fsolve, round brackets. The first input is our equations f. Then, like before, we must give a list of initial guesses. In this case, we will use all zeros. Let's go ahead and print out our solution. Here we get the same solution as before. Now we will solve this nonlinear equation using the two functions as before. Once again, we must first declare our equation. We'll call it f, and here I will use params as our input. In this equation, we only have one variable x equal to params at 0. Then we will return our equation. Even though we only have one equation, we must still return it as a list. So now we can write out our equation. Now we will set our solution equal to root, then pass in our equation, and then our initial guess, we'll use negative 1. And let's print out our solution. So here we get the detailed solution. To just get the value of x, use .x. And here we see x equals negative 1.61. However, there are multiple solutions for x, but root will always return the closest solution to the initial guess. In this case, negative 1.6. To get the other solution, we can change our initial guess to 1. As you can see, we get 0.618. Let's copy over the function to fsolve, and we will set our solution equal to fsolve, pass in our equations, and our initial guess will be negative 1. Let's print out our solution. So once again, we get negative 1.618. To get the other solution, change our initial guess to 1, and we get 0.618.